Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, how are you today? I hope all of you in good condition. First of all, I would like to say thank you to Allah Subhanahu wa Taala who has granted us mercy and blessing. So even though we only give the material but the presentation in online, I hope all of you can catch the material clearly. Amin. And also, I would like to say thank you to Miss Natalia Anggrarini who has give us the time to make the video and then make the presentation in online. Also, share the presentation in YouTube channel. Before we are going to deliver the material, let us introduce ourselves. My name is Indah Triana Sari and my partner are Melawati, Yulita Amalia Dwi Wulandari, and also Muhammad Abizar, and the last one is Nana Nadia. Ladies and gentlemen, the material that will be delivered in our group is about reason development. Reason development, there are 3 points that will be explained more, such as the internet, simulation, and also needs analysis. And the first material, it will be delivered by me. Talking about the internet is globally connected network system facilitating worldwide communication and access to data research to a vast collection of private, public, business, academic, and government networks. It is governed by agencies like the Internet Assigned Number Authority, or we can say IANA, that establish universal protocols. From the internet, we can get so many research or information, such as from online journals, ebooks, blog, and etc. So, in other words, we can say that the internet is a communication network that makes us easy to get the information or share the information that we have now. Yeah. So not only we get research, but also we can share the research that we have done. Online journals, abstract, and title enable research to identify the cutting edge of research and to initiate a literature search of relevant material on their chosen topic. Website and email correspondence enable networks and information to be shared. So, as I say in the previous slide, that from the internet, we not only get the information or many research, but also we can share our information or the research that we have done. And this is the example of educational website that we can access, for us to get the literature or research. We can search in the website of American Educational Research Association or European, or also there are the website from UK. Yeah, you can search or access it in that website. Try it. And the next slide is about finding research information were not available from database and in the case on CD-ROMs, and is often done through the internet by trial and error and serendipity, identifying the keywords to unlock the doors to website. For example, in such terms as Educational Research UK or Educational Research USA or American Educational Research Association or British Educational Research Association, to a search engine will reveal a plethora of websites that are useful. So we can type the key of that website that will make us easy to unlock the educational website that we want to access. The next material is about simulation. Simulation are instructional scenarios where the learner is placed in a world defined by the teachers, and they represent a reality within which students interact, and the teacher control the parameters of this world and use it to achieve the desired instructional result. Students experience the reality of the scenario and gather meaning from it. And for example, the pilot will do the simulation before they fly in the real air, in the real flight, yeah, or before they take off with the real passenger. They have to do the simulation to prepare the pilot that something happen in an expectation of the pilot. So it is important in the recent development to make the simulation before doing something that in the real. Simulation have two main components, such as a system in which the researcher is interested and that lends itself to be modeled or simulated, and a model of that system based on Wilcock in 1997. The system comprises a set of interrelated features, whilst the model that is the analog of the system is usually mathematical. Wilcock in 1997 has indicated the form of simulation. First, in deterministic simulation, all the mathematical and logical relationship between the components of a system are known and fixed. And the second one is in stochastic simulation. Typically, the main types used in educational research, at least one variable is random. Okay, thank you for your attention, and the next material, it will be delivered by Muhammad Abizar. Time is yours.
Okay, for the next simulation is focus is on the trailing edge of weakness rather than to the successful aspect of the organization and its operations. The practice proceeds on the premise that unhacked minor flaws and errors could escalate into huge failure at a system level. The view of chaos theory discussed below. Okay, for the next one is from the 1960s. This view has been increasingly challenged with the rise of theories of chaos and complexity. Central to the chaos theory are several principles, e.g. Gleick 1987, Morrison 1998. Small-scale change in initial conditions can produce massive and unpredictable change outcome. E.g. butterfly swing beat in the Caribbean can produce a hurricane in America. Very similar conditions can produce very dissimilar outcomes using simple mathematical equations. Stewart 1919. Regularity and conformity break down to irregularity and diversity. Even if differential equations are very simple, the behavior of the systems that they are modeling may not be simple. Effects are not straightforward continuous functions of causes. The universe is largely unpredictable. If something works on once, there is no guarantee that it will work in the same way a second time. Determinism is replaced by indeterminism. Deterministic, linear, and stable systems are replaced by dynamical, changing, evolving systems and nonlinear explanation of phenomena. Continuity is replaced by discontinuity, turbulence, and irreversible transformation. Grand universal all encompassing theories and large scale explanation provide inadequate accounts of localized and specific phenomena. Long term prediction is impossible. Simulations are an emerging field in educational research, though they have been used in the natural science and economic for forecasting for several decades. For example, Lewin 1993 and Waldrop 1992 in the study of the rise and fall of species and their behavior indicate how the consecutive iterations replace repeated calculations of simple formula to express the iteration of a limited number of variables, initial conditions, wherein the data from one round of calculations are used in the next round of calculations of the same formula and so on. Building in continuous feedback can give rise to a huge diversity of outcomes, species of behavior, such that it beggars simple prediction or simple cause and effect relationship. So for the case feature simulations are the computer can model and imitate the behavior of system and the major attributes. Computer use can help you to understand the system that is being imitated by the simulation in a range of imitated environment, enabling researchers to see what happens if the system is allowed to run its course of if variables are manipulated to be able to predict. And the last one is the mathematical formula models and interprets, represent and process key features of the reality rather than catching and manipulating the fine grain of reality.
Okay, the next material we will deliver by me, and in the field of education, what is being suggested is that schools and classrooms will being complex, non-linear, dynamical systems can be understood in terms of the working out of simple mathematical modeling. Teams argue that the analog fits the reality, then researchers have a powerful tool for understanding such complexity in terms of the interplay of key variables or initial condition and a set of simple rules. And then there are three immediate applications of simulation have been in the field of educational change, inspection, and school effectiveness. The first, Ridgway argued that the complexity of the change process might be best understood as a complex emergent system. And then second, STEAM exposed some major flaws in the inspection process. And last, teams indicate the limitation of linear input and output or multi-level modeling to understand or explain why schools are effective or why there is such a range of variation between and within schools. Times indicate the limitation of existing schools' effectiveness research that is based on linear premise. Teams argue that simulation models would suggest that even if it were possible to arrange for exactly the same classes to have exactly the same teacher for 2 years in the same classrooms, living through the same 2 years, that the outcomes would not be the same. Next slide is the same material. To the charge that the simulation can never tell us anything,
that we don't already know, that it's no better than the assumption on which it's built, and that a computer can only do what it's programmed to do, rendering human agency and freedom insignificant. It can be stated that Durkheim said simulations can reveal behaviors that occur behind the back of social actors. There are social facts and patterns. While Simon said simulation can tell us what we don't know, we may know premises and starting point, but not where they might lead to or what they imply. And then we don't need to know all the working of the system to be able to explain it, only those parts that are essential for the model. Okay, the next material is other concern can be voiced about simulation. For example, complexity and chaos theory that underpin many mathematical simulations might explain diverse variable outcomes as in school effectiveness research. But how do they enable developers to intervene to promote improvement? How does one ascertain the key initial condition to build into the simulation, and how do simulation from this lead to prescription for practice? And then how acceptable is it to regard system as recurring iteration and reiteration of the same formula or model? And the next, in understanding chaotic complexity in the scientific sense, how can researchers work back from this to identify the first principle or elements or initial conditions that are important? The complex outcomes might be due to the interaction of completely different set of initial conditions. It is impossible to infer a particular stimulus from an observation of behavior. We cannot infer a cause from an observation or putative effect. And then simulation work out and assume only the interplay of initial condition, thereby neglecting the introduction of additional factors. The process is too deterministic. And then what is being argued here is common sense, that the interaction of people produce unpredicted and unpredictable behavior. That is also its greatest attraction. And then planned intervention might work at first, but ultimately don't work. All we can predict is that we cannot predict. And then manipulating human variables is techniques. There is more to behavior than the repeated iteration of the same mathematical model. Whilst they may enable us to understand why there are variations in effects, simulation don't help us to establish causes or intervention. And then the next, there will always be a world of difference between the real world and the simulated world, other than at an unhelpfully simplistic level. And the next, As with other numerical approaches, Rudolph said that the simulation might combine refinement of process with crudity of concept, and then reducing the word to numbers, however sophisticated as quite simply wrong-headed. The word is too complicated for numbers. These criticisms are serious and indicate that this emergent new field of research has much to do to gain legitimacy. This is not to dismiss this important and growing area. Rather, it is to seek its advance. These reservations at conceptual and practical levels do not argue against simulation, but rather for their development and refinement.
Hello everyone. In here I want to deliver about the needs analysis. Needs analysis. The notions of needs analysis, also called needs assessment, has existed in the world of education for over a decade, coming from social welfare, housing, employment, health programs, and social policy research. Its pedigree in education is rooted in evaluation studies and research. Needs analysis can be used, for example, to identify students' instructional needs, identify program provision needs, ascertain weakness in student achievement or provision, provide information on in-service needs, and determine where deficit exists so that they can be addressed. And the last is identify areas for expenditure and educational development. Needs analysis can be argued that needs assessment has similarities to the cause and effect quality models used in industry, where the intention is to find the real cause of problem rather than, for example, putative sources, so that causes rather than symptoms of problems. Deficit and weakness can be addressed in subsequent planning. For example, a need can be defined in several ways. Discrepancy of underachievement, a difference between what is and what should be the case, one's preference reflecting values, anticipate requirements for the future, anticipated problems for the future, and the 5 is deficit, where the absence of a feature under review is harmful. Also, needs analysis is research designed to render decision-making informed rather than conjectural and speculative. There are several components of a needs analysis. First is about the appreciation of the term. It is necessary to address key issue. The definition of need, the nature of the actual problem, the indicators of the need problem, the size of the need or problem, the type of need or problem, the scope, complexity, and range of the problem. The 7 is the sub-element of the need or problem. The 8 is the priorities of the aspect. The 9 is the severity of intensity of the need or problem. The 10 is the causes of the need, and the last is forecasting needs. In terms of the population concerned, it is necessary to address several factors. The target population for an intervention, the number of people affected or concerned, the location of the need or problem, and the 4 is the clarification of whose problem it is, and the 5 is the density and distribution, and the next is the incidence of the problem. How widespread is the need? The last is how widespread is the need. In terms of a proposed intervention, there are several important factors to address. The first is the identification of the exact conditions, problems, and needs that the intervention is designed to address. Next is the appropriations of the program intended to address the need. And the next is the purpose of the proposed intervention. and the 4 is the boundaries of the target population for intervention, and the 5 is the present and estimated future size of the target population, and the 6 is the feasibility of the proposed intervention, and the last is responsibility for intervention, which people have to take action. Okay, maybe that's enough for me, and the next presenter time is yours.
Okay, I'm the last presenter, so I would like to tell you about the data required for needs analysis. There is qualitative and quantitative data for needs analysis. So, as we know, the success of needs analysis could depend on the careful and appropriate sampling and targeting of parties concerned. Like according to Rossi and Freeman 1993, suggests that qualitative data are useful for determining the nature of the need, whilst quantitative data are necessary for determining the extent of the need. So the issue of sampling and targeting is not unproblematic for issues of inclusion in and exclusion from. The sample or target population might be highly sensitive, like for example, needs analysis of children at risk of abuse or poor parenting, or the criteria to be used for defining students who are developmentally delayed. Further, it is possible that a need or problem will be conceptual as more data are obtained, the sample is within the number of stakeholders in place, and further evaluation studies are undertaken. Like for example, is problem which might be perceived initially as the incidence of noisy students in a school corridor might turn out to be manifestation of diverse set of problems. And then a need analysis then identifies the problem or need and then proceeds to identify the aims, content, implementation, target population, and outcome of intervention. So in this respect, it is akin to planning action research. So the important then for the researchers to be clear on the purposes of the needs analysis being undertaken. So for this will determine the focus, methodology, and outcome of this assessment. Consequent to this, it is necessary for the needs analysis to be clear on its limit, focus, sampling, methodology, data collection, and perception or intervention. And the next is, according to Land and Mackenzie 1981, suggests that the process of prioritization will need to focus on such issues as there is the consequence of not meeting the need, and then the number of people affected, and the meeting of the need by the parties identified, and then the criticality and severity of the needs, and the sequencing of the needs, the order in which the needs, so the resources implication of meeting the needs, and then the last is the scope of the outcome and the utility of the intervention. And then the next slide is, according to Swartz 1994, that suggests research funding to be planned and to extensive. The critical factor of a needs assessment, like many evaluation studies, is the utility of the findings. The outcomes of needs assessment should feed into decision making and policy formation. Hence, all stakeholders needs to be involved in form of the research. So, in planning a needs analysis, then four main steps can be followed. The first step is decide the purpose of the needs analysis, and then the second is identify the focus of the needs analysis, and then the third is decide the methodology, sampling, instrumentation, data collection, and analysis procedures and criteria to be used to judge the stage, and then the fourth is decide the reporting and dissemination of the result. So it can be seen that the planning of a needs analysis follows a typical plan of an evaluation or evaluative research. For an extensive examples of needs analysis, like according to Kirsch 1999, analysis of in-service needs for staff development and curriculum change. Internet material on needs analysis in education can be found by keying in education needs analysis or education needs evaluation on search engine. However, it must be stated that the overwhelming amount of internet material here concerns business and financial needs assessment, management training needs, and IT needs assessment. So, though there are isolated instances of educational materials, and then often of an advertising nature and often concerning special education needs. Okay, that's all the material from us. Thank you for your attention. And last, wassalamualaikum warahmatullahi wabarakatuh.